Hi, Algebra 2. I just wanted to go over the problems I graded on the previous homework on page 177. First one I graded was number 12. You have x cubed plus 64. There's two terms, perfect cubes. How do I know they're perfect cubes? I wrote them out here on the next slide. Here, 2 cubed, 3 cubed, 4 cubed, 5 cubed, 6 cubed. You can see below. You're looking for things that are like 8, 27, 64, 125, and 216. Really, most of the time it's going to be 8, 27, or 64. They don't get too high on these. So here I'm going to just work this out. This is the equation a plus b, a squared minus ab plus b squared. And just fill in everything. A on this one's going to be x, because I take the cube root of x cubed and get x. B is going to be the cube root of 64, which gives you 4. So A equals x, B equals 4, and now just plug in everything. You get x plus 4, x squared minus 4 times x, and square B, which gives you 16. So this is the answer for problem number 12. Realize I'm out of order here, but here's example number 4, or problem number 4. 4 terms, factor by grouping. Both of these have x squared in common. It gives you x plus 1. If I look over here, I don't have x plus 1, so I need to factor out a negative 1, and now I get x plus 1. If I redistribute those, negative 1 times x is going to give me negative x, which is above, and then negative 1 times positive 1 is negative 1. And now I'm going to do the distributive property again. They both have x plus 1 in common, and what's left over is x squared minus 1. Thing to realize, x squared minus 1 are perfect squares, so I can reduce that also to x plus 1 and x minus 1. So here you get 3 binomials for this answer. So problem 20 is the next one I graded, pretty similar to the last one I just did. 4 terms, so we're going to factor by parts here. I have 4y squared, goes into both, and you get 2y minus 1. I'm going to look for that 2y minus 1 over here on the right, so if I factor out 25, I get 2y minus 1. I can double check. Negative 25 times 2y does give me negative 50y. Negative 25 times negative 1 does give me positive 25, so it looks like it is factored correctly. Next thing I'm going to do, they both have 2y minus 1, factor that out, and then it's just what's left over here. So 4y squared minus 25. And just like the last one, 4y squared and 25 are both perfect squares. You can split this up into 2y plus 5, 2y minus 5. Next one I graded was 28. You got 24n squared plus 3n to the 5th. My guess is it's going to be a perfect cube. I have to do a little bit of work to get it there. There's 2 terms, kind of my clue there. So I'm going to factor out 3n squared, and I get 8 plus n cubed. 8 is a perfect cube, 2 times 2 times 2. N cube's a perfect cube, m times n is n cubed. So I can use the formula that I used on the first problem I did, which was 12. So I take the cube root of 8, which is 2. I take the cube root of n cubed, which is n. So it's a plus b, then it's a squared, so 2 squared, minus a times b, so 2 times n, and then square the last term, which is n squared. And I'm just using the cube formula that I gave on page 12. I guess I can rewrite it here. It's a plus b, a squared minus ab plus b squared. And your answer is right there in the middle. And last problem, 42, gives you factor x minus 1. Does this factor into p of x? So I set up synthetic division here. Remember, factor form, it's x minus 1. You have to set that equal to 0 and solve for x. And when you do that, you get 1. Coefficients just match. So 4 here matches here. Negative 4, negative 4, negative 2, and so on. I checked to make sure there was no 0 terms. So I got x to the 6th, x to the 5th, x to the 4th, x cubed, x squared, x, and a constant. so I don't need any zero terms. And now I just do synthetic division, so bring down the first term, multiply when you're on the outside, add when you're in the middle. So multiply again, add, multiply, add, multiply, add, multiply, add, multiply, and it does work. The second part of the direction says use synthetic division to write the polynomial as a product. The product's going to be x minus 1, and then remember it's remainder, constant, x squared, x cubed, x to the fourth, x to the fifth. So I got 4x to the fifth minus 2x cubed plus x squared minus 7. I don't need to write 0x to the fourth or 0x or 0 remainder. So now I have a product of two polynomials, and that's 42. I realize I went through this really quick, but hopefully you get some ideas. If you have questions, feel free to come back and ask, and I'll explain it better. Thanks.